So the first thing we wanted to do, and I strongly encourage you to take a look at our course schedule. You'll see that the first 3 class sessions are devoted to reading literature, coming up with ideas, and then deciding when an idea is good, okay? And so we really want to emphasize to you that you can do this. You can come up with ideas, and you can start being that independent scientist. I know you're young. I know that you're only in your first year, but we got to start now, because you're going to build on those ideas as you go through your graduate career. Now, the first key thing you need to learn how to do to find a new idea that's your own, that you can be proud of, is to read papers. So what I want to do in this short presentation is to talk to you about how to read papers, and then I'll give you our assignment for next time. Okay, so I was actually inspired by a paper that I read about how to effectively read scientific literature. So why do we need to learn how to read scientific literature? And I came up with three things that I thought were really important. First of all, at this stage in your career, you need to read background papers in your research, on your research project in your PI's lab, so that you can get to know the goals and the rationale for your project. So reading these background papers really allows you to start being the intellectual driver in your project. So hopefully you guys have already started reading papers related to your research in the lab. That way you're already familiarizing yourself with papers. Keep reading, because you'll need that background for your own projects. Now, beyond then what you're learning in your own lab, reading the literature will allow you, and really attending seminars. Seminars are an easy way to do this also. But for now, let's talk about the literature. You should become a well-rounded, informed scientist, so that when you go for that job interview someday and it's not in your immediate research area, you can still have a very thoughtful conversation about science. So your job at this young stage is to start exposing yourself to science so that you become an intellectual driver even outside of your research area. If you think you're going to be doing exactly the kind of work you're doing right now in graduate school, after graduate school, that is not how it works. You need to become apt at reading and understanding the literature so you can learn outside of your normal area. And then finally, for this class, the literature is a source of generation of new ideas. As you read a paper, you can come up with a new idea based on that paper, and that can really be helpful for you to come up with that proposal idea that you want to write on. So, but the first step is to read the literature. Okay, so I wanted to also debunk a few myths. I want to make sure you guys all feel empowered to be able to read the literature. The first myth I want to debunk is that good scientists were born knowing how to read the literature. That is absolutely not true. Absolutely 100% wrong. The fact is that learning to read scientific papers, learning to extract new ideas from those papers is a skill. You have to learn how to do it. You have to practice it. You have to keep working on it to get better and better at it. You have to start today, okay? So as you go through this class, as you go through your graduate training, you're going to get better and better at reading papers. I guarantee it. But you have to start somewhere, and it's going to be today. And even if you don't feel good about it, you got to start, okay? The second myth is I can only read papers that are in my immediate research area. Absolutely not. You want to branch out, read papers outside of your comfort zone so that you can become that educated, thoughtful scientist that a company or an academic university or an institute is going to want to hire. So please realize that you need to focus on these skills so that you can become that thoughtful scientist. Okay. I was inspired thinking about how to talk to you about reading the literature from this paper, which actually is an undergraduate. It's for undergraduate laboratories, but they use this method called CREATE, which says, while you read the paper, you want to consider, read, elucidate the hypothesis, analyze and interpret the data, and think of the next experiment. And it's this think of the next experiment. Think of the next experiment. This is a new idea, okay? Because the next experiment has not yet been done, and it's what would logically happen next. Now, I'm not going to go through the full document here. This is actually meant for undergraduate classes, but if you find that you need more help than what I'm providing you here, I highly recommend that you look at this document because it goes through some other pedagogical tools that might be helpful to you. I think at this stage, you've probably already been exposed to the literature, so I'm going to assume we don't have to go through all of it. And what I'm going to do instead is focus on something that I found really interesting. I actually only discovered this idea of reverse outlining in the last 6 months or so when I was trying to train my own students in my own lab about reading papers. And so reverse outlining is this method where you construct an outline in reverse of a paper that's already written. And I think it's really a helpful way of distilling the ideas of a paper relatively quickly. So here's the process. And this is something we're going to do together. And this will be the basis of the assignment that we'll give you. Here's the idea. You read the paper, you read a paragraph in the paper, you focus in on one small chunk of the paper. In the next step, once you've read that small chunk of the paper, the paragraph, let's say, in the margins next to that paragraph, or you can use a separate sheet of paper, either way, summarize the main point of that paragraph. Do not use complete sentences, just keywords and phrases, just so that you can get the idea. So you're basically just summarizing what you've read. And then what you're going to do is walk through that paper, and each point where you feel like you have a new topic that you've raised, write another note until you get to the point where you've walked through the paper and you have an idea of the full paper. And let me emphasize that you want to still do this for the experiment. So also do this for any figure in the paper. In that case, with an experiment, you want to focus on the goal of that experiment and what the results told you about the experiment, the conclusion. This is important because when it comes down to generating ideas, you have to be able to also propose experiments to test those ideas. So you really need to read primary literature so you can look for those experiments. Okay, does that make sense? So this is what reverse outlining is. Read a part of your text in your paper, summarize in the margin, read more, summarize, read more, summarize until you get to the end. Okay? Okay, so what can this do for you? A reverse outline like this allows you to quickly draw out the main ideas of the experiment. What was the gap in the field? Every paper was trying to solve a problem. What was the gap in the field? What was the hypothesis tested? That's the important thing in the beginning. Now, when you get to the experiments, what was the goal of the experiment and what was the conclusion of the experiment? And the beautiful thing is when you get to the end of the paper, after thinking about all of the different pieces of all the summarizing all the different pieces, you should be able to do the most important thing, which is to think of the next logical experiment. And that next logical experiment, folks, is a new idea, okay? So every paper that you read should give you a new idea. And let me be clear, though, that this is not just for primary research articles. Remember, primary research articles are ones where they do experiments. This is also true of review papers. And we'll talk about more of that next time. Today, what I want to do is focus on how to do this reverse outlining with a paper. And so this is what we're going to do for the next, I'm running out of time. It's already 6:49. So what I was going to do, maybe I'll just go through this really quickly. What I wanted to do is just let's do one real quick in-class exercise. I won't be able to go through this because we've run out of time. But I'm going to pull up a paper. This is one I got from Jax. It's a super short paper. Where is it? Here we go. It's a super short paper from Jax. And I picked this one. I thought it was cool because it's about viral detection of viruses. And given COVID-19, I thought it would be cool for us to talk about how ways that we can think about doing science to identify viruses, which I thought was neat. So this paper, you can read the title. Viral-induced self-assembly of magnetic nanoparticles allows the detection of viral particles in biological media. So why don't we do this? Why don't you read about halfway through this paragraph? I think this half of the paragraph, this is a communication from Jack, so it's really jam-packed with information. If you read this section, why don't you put in the chat maybe some text that would summarize that section of the paper? And I'll write it here for us.
This is also a paper from one of the godfathers of molecular imaging.
It's actually a lovely paper. And if any of you have interest in generating an independent proposal based on COVID-19. This would be a great starting point. I thought I'd put that little out there because I would love to see proposals on COVID. What fun, huh?
Dr. Pflum, can you maximize the window so
Oh,
we
yes.
will be able to
I apologize. Thank you for that comment. Yes, so that you could read it better. Is that better now?
Yes, it is. Thank you very much.
Great. So just read the part in blue. Any ideas on, you guys can maybe just say it because this should be short. I don't need it in the chat. I can just say short. What are some key words that you guys want to remember from this one? I'm ready to write. You unmute yourself and let me know.
Supramolecular structures.
So supramolecular structures. And what about them?
Supramolecular structures which can help to which can help in designing nanoparticles to detect viruses.
That's it. So supramolecular nanoparticles can detect viruses, right? That's the point of that part. So you distill down the information. It's all wordy, right? It's so many words, lots of nanoparticles, supramolecular. You distill it down to its essential parts. And then what you'll read is the next part is we have previously done this. And we didn't just do it, we used relaxation time in MRI to do this, right? And if you keep reading now, you can now start reading. So this would be a fun paper for you to work on. I just was going to use this as an example. This is not part of your homework, but I wanted to emphasize that this is the way to really quickly distill down information. I am not a nanoparticle specialist, but I really did enjoy reading this paper. I thought it was quite interesting. So anyway, take that advice. Okay, so I want to finish up in the next few minutes so that I can get you to your breakout sessions. Ed and I knew that this would be a relatively long class. We had a lot to cover. We promise it won't be so bad next time, but today was a little bit special. Let me just finish by saying that your homework assignment, which is due by 5:30 before class our next time, we meet Thursday the 14th in a few days, is what I want you to do is to reverse outline an assigned paper. And each of you has been assigned a paper based on your peer mentor group, the same peer mentor group that you will be meeting with right after I finish talking right now. So you can see each of the peer mentors I've indicated the peer mentor's name at the top, along with the students in that group. And then here is the paper and a link to that paper. This is also available on Canvas under the assignment instructions. If you are confused at all, just email Ed and I and we can just send you the link. But this gives you the paper you are covering. Each group will cover one paper, and then after our class on Thursday, you'll come together to discuss that paper together. Make sure that you guys all kind of came to the same conclusions about your papers, okay? These are a bit longer paper than the one I chose for our example. So leave yourself some time to do it. If this paper that we've chosen for you is not in your comfort zone, all the better. This is how we learn how to read papers that maybe are not exactly what we were planning on, okay? So you're just reverse outlining one paper for your next assignment. Please read the instructions. What you will do is once you reverse outline that paper, you can write in the margins just like I did on the PDF file. You can handwrite it and scan it in. You can write on a separate piece of paper, make a PDF. No matter what you do, you are uploading the assignment into the submission site for that assignment in Canvas. Please do this early because many of you may not have done this before and we really want to make sure you get those points. For these first few lectures, we will take the assignment by email because we know you're learning, but you absolutely have to get these into Canvas eventually. So try really hard to do it this time. Okay, the only thing I have left in this slide is just to give you some references for reverse outlining and the create method. are there any questions before we adjourn and you guys will move to your breakout sessions with your peer mentors? They'll just they just want to introduce themselves and do a little icebreaker with you.
I'd like to add a few words.
Yes, Ed,
basically,
please.
yeah, what I'd like to add is I completely, definitely agree with what Mary Kay just described. Scientific writing, it's just like a skill. You really, really need to practice it. And my personal suggestion is, make sure to find yourself an exercise on scientific writing every day. And I don't mean this particular class, in general. Make sure to find yourself a task to write, 1 page of scientific writing relevant to what you do, whether it's an experiment that you could be planning or an interesting paper that you're reading or some future outline of the experiments. You really need to practice that.
And that's what we're here for. We're practicing it. That's what we're going to do. You will not be an expert at the end of this class, but you will be on the road. You will be on the road to becoming an expert. So, okay. Any questions about this? Again, the instructions are on the website, so you can read those more thoroughly. Just to remind you, we're going to adjourn this class, and then remember, you're going to go and re-sign into the Zoom chat rooms for your peer mentor. For this class, there's no assignment. You're just going to introduce yourselves and do a little icebreaker and get to know each other a little bit. Starting next class, the peer mentor sessions, you'll be talking about your assignments.